Hey, welcome to the 25th session for the flipped classroom. This was kind of an unexpected thing, but some of you guys said you'd like to see a solution to maybe one of the harder problems. So I picked probably one of the harder problems. It's problem 24 in section 3.5, and we're going to go over the solution. Okay, hopefully we can read this. The problem is they draw this trough, and they ask you what value of theta maximizes the trough's value, okay? So the cross section of this trough is really a trapezoid, okay? And the trapezoid has, at the bottom base, it's 1, and I've denoted that by an A. The top base is B. If you remember from geometry, the area of a trapezoid is A plus B divided by 2 times the height, okay? So that's just the cross section. And then to find the volume of the trough, you would have to multiply the area of the trapezoid by 20 feet. Okay, let's work on a formula that involves theta because they want to know what value of theta maximizes the trough's volume. Okay, well, I can denote the area of the trapezoid a different way, and you need to sort of pay attention here. Okay, I can express the top base, this B, by 1, which is the interior portion, because for this portion right here, B equals 1, and then this little part is actually the opposite side of this right triangle, who has angle theta. Okay, and since opposite over hypotenuse, and if you notice, the hypotenuse of that triangle right here is 1. So I could say that this little opposite side right here is equal to the sine of theta. Okay, because opposite over 1, the opposite side would have to be equal to the sine of theta. Since I have 2 of these, I could express this top base of the trapezoid as 1 plus 2 sine of theta. And if you look down here in this formula, I've got that right there. And then I express the bottom base, A, as just 1. And then we're going to divide that by 2. The height, well, if you look at it, the height is really the adjacent side of this right triangle, and adjacent over hypotenuse. Remember, the hypotenuse is 1, so the adjacent side, or the height, would just be equal to the cosine of theta. So the key to this problem is coming up with this formula for the area of the trapezoid. Now, if I just multiply it by 20, which is the length, now we have a formula for the area, the volume of the trough. Okay? All right, next slide. Okay, here's what I've done to this formula. Okay, since it was 20 and it was over 2, I made this a 10. And what I did is 1 plus 1 was 2 in the previous one, and we had 2 sine of theta. Okay, times cosine of theta. Now what I'm going to do here is I'm going to multiply the 10 across these brackets, okay? And so when I multiply the 10 across these brackets, I get 20 times the cosine of theta plus, I'm not going to multiply it, and you'll see why in a minute, I get 10 times 2 sine theta cosine theta. You follow that? Okay, the reason I didn't multiply the second term out is that there's a trig identity that says the sine of 2 theta equals 2 times the sine of theta cosine of theta. So I'm going to substitute the sine of 2 theta in here where I had 2 sine theta cosine theta. Okay, so now I have my formula, if you will, for the volume of the trough. I'm going to take the derivative. V prime is going to be negative 20 sine of theta plus 20, because you've got to use chain rule on that sine of 2 theta, don't forget, cosine 2 theta. I'm going to set it equal to 0. I get 0 equals negative 20 sine of 2 theta plus 20 cosine of 2 theta. Add the 20 sine of theta to both sides. Okay, so I get 20 sine theta equals 20 cosine of 2 theta, and therefore sine of theta has to equal cosine 2 theta. So how do you solve this? Well, we're going to go back and use a trig ID. The trig identity I'm going to use, and it's a little blurry here, says that the cosine of 2 theta equals the cosine squared of theta minus sine squared of theta. So where I see the cosine of 2 theta in my equation, I'm going to write cosine squared theta minus sine squared theta. So what I get is sine of theta, left-hand side, equals cosine squared theta minus sine squared theta. Okay, you may remember another trig identity that says sine squared of theta plus cosine squared of theta equals 1. If that's true, the cosine squared of theta must equal 1 minus the sine squared of theta. So what I've done in the next part is I've replaced cosine squared of theta with 1 minus sine squared of theta. Okay? So now I combine like terms and I do a little rearranging. I'm going to set this equal to 0. Okay, because keep in mind, we're still trying to find critical numbers. And what I get is 2 sine squared of theta plus sine of theta minus 1 has to equal 0. Now that's a quadratic, and it can be factored, okay? And I factor it to 2 sine theta minus 1 sine of theta plus 1. Okay, this can equal 0 when sine of theta equals negative 1. Okay, that would happen at 3 pi over 2 or 270, which really doesn't make any sense because you can't have two angles with the trapezoid of that angle. Or it will happen when sine of theta equals 1/2. Okay? And that does happen when theta equals pi over 6 or 30 degrees. Okay, so that's our critical number. So now what we need to show is that is a maximum. So I take the second derivative here from my first derivative, and I get negative 20 cosine of theta minus 20 sine of 2 theta. If theta is pi over 6, okay, negative 20, the cosine of pi over 6 is root 3 over 2. The sine of not pi over 6, but actually pi over 3, because it's 2 theta, okay, and pi over 3 is 60 degrees, is root 3 over 2. So I end up with a negative 20 root 3 over 2 minus 20 root 3 over 2, which is 40 times root 3 over 2, negative 40, I'm sorry, which I know has to be negative. Therefore, it's a maximum. Okay? I hope this helps you out a little bit, and Edmodo me if you have any questions. Thank you.